Okay, Spearman's rank correlation coefficient is used in a similar way to the product moment correlation coefficient to try to find out whether there is a correlation between two sets of variables. The difference between Spearman's really and the product moment correlation coefficient is that Spearman's is used when you have data which is ranked. In other words, someone or something has somehow ordered the data, usually by using some sort of test. Product moment correlation coefficient is used more for things like the Hooke's law experiment, where you're hanging weights on a spring and looking at how much the spring is stretching. So perhaps you're looking at more at continuous data like weights and heights or something. Anyway, let's have a look at how Spearman's rank correlation coefficient works. So here's a question where two different commentators, commentator 1 and commentator 2, were asked to give ratings to 7 different sports personalities. So the sports personalities A, B, C, D, E, F, G, and each commentator was asked to give that sports personality a mark out of 100. So commentator 1 gave A 73 out of 100 and B 76 out of 100. And we're just going to see whether there's any agreement, if you like, between commentator 1 and commentator 2. Now, it usually starts out easier if you can make a table, in other words, get your data arranged vertically rather than horizontal. So I'm going to start first of all, but I'm just going to pause this and start making the table. Okay, you can see all I've done here is I've rearranged the horizontal table with the personalities A, B, C, D, E, F, G, and then the rating, which is given by each of the commentators. What I'm now going to do is I'm going to rank those ratings, and this is where Spearman's comes in. So I'm going to work out which position each of those commentators put the different sports personalities. Now the rank, I'm going to call, in fact, let's get rid of that. We normally call the rank X and Y. So I'm going to call the first one here X. So that's going to be referring to the rating for commentator 1, and then Y is going to be the rating for commentator. Okay, so let's get started then. Now, if we look at the first commentator, we can see that he's put G the highest. In other words, he prefers that one, so I'm going to put that on at number 1. The next highest is E, so he's going to be second. Then we've got F, third. Next one is this one, C, which is going to be 4th. 5th, we've got B. 6th, we've got A. And in 7th place is personality, D. Now, if we do the same for Y, now top position there, he's also got G. In 2nd position, we've got F. 3rd position, we've got E. In 4th position, D, so they disagree there. 5th position, he's got C. 6th position, and 7th position, he's put A. Okay, the next thing we do is we work out the difference between the ranks. And what you can see is if these ranks are very close to each other, then the difference is going to be 0. So what I'm going to do, I'm going to work out the difference between the ranks. Now we call that D, and D is always equal to X minus Y. Okay, so let's do those. 6 take away 7 is minus 1. 5 take away 6 is minus 1. 4 take away 5, minus 1. 7 take away 4 is 3. 2 take away 3, minus 1. 3 take away 2 is 1. And 1 take away 1 is 0. Now, if we add these up, what you should find, and you'll always find this if you've done it correctly, is that the sum of the D column should be 0. Well, let's just check that. You've got 3 and 1 add up to 4, and then you've got 4 minus 1s, which makes minus 4, so those add up to 0. What we now do is we square each of those values of D. So in other words, we make another column, and we call that column D squared. So I'm going to square each of these. So minus 1 squared is 1, minus 1 squared is 1, minus 1 squared is 1, 3 squared is 9, minus 1 squared is 1, 1 squared is 1, and 0 squared is 0. And all that happens there is that makes all of those values positive. Now, this is the important column. The sum of that column we call sigma D squared. So if we add these up, we've got 9 plus 5, which is 14. Okay, now we're ready to work out Spearman's rank correlation coefficient. And we give that the letter R, but with a little s to show that although it's a correlation coefficient, it's Spearman's correlation coefficient. And the formula, which you need to learn here, you're going to do 1 minus, and then it's 6 sigma d squared divided by n multiplied by n squared minus 1. And n is simply the number of pairs of data. Okay, so let's carry on. So in this case, we're going to do 1 take away. Now, sigma d squared was 14. So we're going to be doing 6 multiplied by 14 divided by, now in this case, n is just the number of pairs, and we can see in this case that n is equal to 7. Okay, so here we're going to do 7, and then 7 squared, well, that's 49 minus 1. Okay, if we just carry on then, so 6 times 14, well, that's 84. And this, the bottom here becomes 7 times 48. So that's 1 minus 84 over, now 7 times 48 is 336. And if we work that out, so it's 1 minus 84 divided by 336. We end up with 0.75. Okay, so Spearman's rank correlation coefficient in this case is 0.75. Okay, and let's think about now what that actually means. Okay, now basically, if Spearman's rank correlation coefficient is a value close to 1, then what that actually means is you would have a scatter graph where for every increase in x, you've got an increase in y. In other words, you might have points that look something like this. And you can see that for every increase in x, you've got an increase in y. So increase, increase, to the right, 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 right. If RS, so Spearman's rank correlation coefficient, is approximately equal to -1, that would mean that you had a scatter graph like this, where every decrease in x also is a decrease in y. That wouldn't be any good, that last one. So in other words, you continue going, oopsie, hey, it's something like this. No, no, sorry. As long as it keeps going down, okay. If every down step gives you an across step, that would give you a Spearman's correlation coefficient of approximately -1. Now in this case, we've got a Spearman's correlation coefficient of 0.75. That means that there is a pretty strong positive correlation between the ranks of the two judges. In other words, the judges are in agreement with each other to a fairly large extent. Okay, so here we have two commentators who generally agree on which personalities they think are